Hey everyone, welcome back to the channel. I hope you are doing great. In today's video, we are going to crack one of the most popular interview questions, longest substring without repeating characters. And as always, we are going to break it down with an everyday analogy, explore both brute force and optimal solutions, and discuss their time and space complexity in detail. So let's dive in. Alright, let's start with the problem statement itself. The goal is simple. Given a string S, find the length of the longest substring without repeating characters. Now, what exactly does that mean? A substring is a contiguous sequence of characters within a string. So, ABC is a substring of ABC, ABC, BB, but ACB is not. Without repeating characters means that every character within that substring must be unique. No duplicates allowed. Let's dive into some examples to illustrate this. Take this input string. The longest substring without repeating characters is ABC with the length of 3. So the output is 3. Now let's consider this input string. The longest substring without repeating characters is B with the length of 1. Therefore, the output is 1. Lastly, let's look at this input string. Since there are no repeating characters, the longest substring without repeating characters is the same as the input string itself, which has a length of 7. So the output is 7. Let's relate this problem to a real life analogy. Imagine you are walking through a street market and you are collecting unique items from each stall, say a scarf, a bracelet, a mug. But the moment you see a duplicate item, you stop and think, okay, how many unique items did I collect without repeating any? That is exactly what this problem is about. Scanning through a string and finding the longest sequence where no characters repeat. We now understand the problem fully. Before we jump into the optimal solution, let's first look at the brute force approach. It is not the most efficient, but it is a great way to understand the core of the problem. In brute force approach, we check all possible substrings and keep track of the longest one that has all unique characters. Here is the idea. We iterate through all substrings using two nested loops. For each substring, we use a set data structure to check if there are any repeating characters. If the substring has all unique characters and its length is greater than our current max, we update the max length. Let's walk through a dry run with the input string ABC, ABC, BB. Max length is initialized to 0. The outer loop starts with I set to 0. Think of this as setting the starting point of our substring. And inner loop starts with J set to I. This is our ending point, expanding the substring character by character. So the first substring is A. Is A unique? Yes. If the current substring's length is greater than the max length, update the max length. Is 1 greater than 0? Yes. So update max length to 1. Increment J and check next substring. Next substring is AB. Is AB unique? Yes. Is 2 greater than 1? Yes. Update current max length to 2. Increment J. Next substring is ABC. Is ABC unique? Yes. Is 3 greater than 2? Yes. Update current max length to 3. Increment J. Next substring is ABCA. Is ABCA unique? No, because A is repeated. Current max length remains 3. If a duplicate is found, break the inner loop. No need to check longer substrings from the same start. In the first iteration, the longest non-repeating substring is ABC with length 3. Let's check the remaining substrings. Increment the outer loop. I now points to B and the inner loop which starts from I. So next substring is B. Is B unique? Yes. Length of B is 1. Is 1 greater than the current max length which is 3? No. So current max length stays 3. Increment J. Is BC unique? Yes. Is 2 greater than 3? No. Increment J. Is BCA unique? Yes. Is 3 greater than 3? No. Increment J. Is BCAB unique? No. Break the inner loop. Likewise, check all the possible substrings and update the max length whenever we find a longer valid substring. Let's dive into the code step by step. We start with the method called length of longest substring, which takes a string yes as input. Our goal is to find the length of the longest substring without any repeating characters. We initialize a variable max length to 0. This will keep track of the maximum length of unique substrings we find. Next, we run a loop with index I from 0 to the end of the string. Think of this as setting the starting point of our substring. Inside this loop, we create a hash set. This set will store the characters we have seen so far in the current substring and help us quickly check if we have hit a duplicate. Now, we run another loop with index j starting from I up to the end of the string. This is our ending point, expanding the substring character by character. Inside this inner loop, we check, has the character at index j already been seen? If yes, that means we have found a duplicate and we break out of the inner loop. That substring is no longer valid. But if it is a new character, we add it to the set. Then we update the max value with the larger of two values, the current max and the size of the set, which represents the length of the current unique substring. This process continues for every starting index I in the string. And once all substrings are checked, we return the final value of max length. As you can see, this involves checking every possible substring. This works, but this is not the most efficient way. For small string, this is fine, but that is not ideal for large string. This is why we often look for more optimized solutions. Now that we understand the brute force logic, let's level up with a much faster solution using the sliding window technique. Trust me, you will love how efficient and elegant it is. Imagine a window that slides across our string. This window has a left pointer and a right pointer. We expand the window by moving the right pointer, and we shrink it by moving the left pointer. The key idea is to maintain a valid window. In our case, a window that contains no repeating characters. To efficiently check for repeating characters within our window, we will use a hash map. This hash map will store each character encountered within the current window along with its index. This allows us to quickly determine if a character is already present in our window, and if so, where its previous occurrence was. Let's do a dry run with the example string ABC ABC BB. We will initialize our left pointer to 0, our max length to 0, and our hash map as empty. Our right pointer will iterate through the string. Iteration 1. Right is at index 0. Current character is A. A is not in our map. We add A and its index 0 to the map. Our current window is A. Calculate the current length. Current length is equal to right minus left plus 1. 0 minus 0 plus 1 is equal to 1. Maximum of 0, 1 is 1, so max length becomes 1. Iteration 2. Right is at index 1. Current character is B. B is not in our map. Add B and its index 1 to the map. Current window is A, B. Calculate the current length. Current length is equal to 1 minus 0 plus 1 is equal to 2. Maximum of 1, 2 is 2, so max length becomes 2. Iteration 3. Right is at index 2. Current character is C. C is not in our map. Add C and its index 2 to the map. Current window is A, B, C. Current length is equal to 2 minus 0 plus 1 is equal to 3. Maximum of 3, 2 is 3, so max length becomes 3. Iteration 4. Right is at index 3. Current character is A. A is already in our map. This means we have a repeating character. To make our window valid again, we need to shrink it from the left. The new left pointer should be one position after the previous occurrence of A. So, left becomes map.get of A plus 1, which is 0 plus 1 is equal to 1. Now our window is from index 1 to 3, which is BCA. This window is valid. We also update A's index in the map to its current position 3. Current length is equal to 3 minus 1 plus 1 is equal to 3. Maximum of 3, 3 is 3. So max length remains 3. Iteration 5. Right is at index 4. Current character is B. Again, B is a repeat. Left moves to map.get of B plus 1, which is 1 plus 1 is equal to 2. Our window is now from index 2 to 4, which is CAB. Still valid. Update B's index in the map to 4. Current window CAB. Current length is equal to 4 minus 2 plus 1 equal to 3. Maximum of 3, 3 is 3. So max length remains 3. Iteration 6. Right is at index 5. Current character is C. Another repeat. Left moves to map.get of C plus 1, which is 2 plus 1 equal to 3. Window from index 3 to 5, which is ABC. Valid. Update C's index in the map to 5. Current window ABC. Length 3. Max length remains 3. Iteration 7. Right is at index 6. Character is B. B repeats. Left moves to map.get of B plus 1, which is 4 plus 1 equal to 5. Window from index 5 to 6, which is CB. Valid. Update B's index in the map to 6. Current window CB. Length 2. Max length remains 3. We have iterated through the entire stream. Our final max length is 3, which is the correct answer for ABC, ABC, BB. The longest substring without repeating characters is ABC. Now, let's look at the Java code implementation. Let's walk through the code. We declare our hash map named char index map. This map will store characters as keys and their last encountered indices as values. Max length will keep track of our overall longest valid substring, initialized to 0. And left is our left pointer, also initialized to 0. Our right pointer iterates through the string, effectively expanding our window one character at a time. Inside the loop, we get the current char at the right pointer's position. This is the core logic for handling repeats. If our char index map already contains current char, it means we have found a duplicate within our current window. If a repeat is found, we need to move our left pointer. The new left position should be one index after the previous occurrence of the current char. We use math.max here because left should only move forward. If the previous occurrence was before the current left boundary, we don't want to shrink our window unnecessarily. Regardless of whether it's a new character or a repeating one, we always update the char index map with the current char and its current right index. This ensures our map always stores the most recent position of each character. Finally, we calculate the length of our current valid window, which is right minus left plus 1. We then update max length if this current length is greater. After the loop finishes iterating through the entire string, max length will hold the length of the longest substring without repeating characters, and we return it. The sliding window technique combined with a hash map gives us a highly efficient solution. Let's copy and paste the solution into LeetCode. Let's submit the solution. Awesome. Solution accepted and all test cases passed. Let's break down the time and space complexity of both the brute force and sliding window approaches for this problem. Let's start with the brute force approach. In this method, we use two nested loops to try out all possible substrings of the given string. So the time complexity is O of n square. As for space complexity, we only need a set to store characters while checking for uniqueness, which takes up to O of k space. where k is the length of the substring, at most O of n. So space complexity is O of n. Clearly, this brute force method is simple but highly inefficient for larger strings. Now let's look at the optimized solution using the sliding window technique along with a hash map. We scan each character at most once. Both pointers only move forward. That gives us a total time complexity of O of n, where n is the length of the string. And the space complexity? We use a hash map to store characters and their indices. In the worst case, all characters are unique, so the hash map stores n entries. That means the space complexity is O of n. This optimized approach is efficient and works great even for long strings. And that's it. You have just learned how to solve longest substring without repeating characters efficiently. You did not just crack a tricky interview question, you also unlocked one of the most powerful techniques in string manipulation, the sliding window. If you found this explanation helpful, drop a like, subscribe to the channel and comment which problem you would like me to cover next. Thanks for watching and keep coding smart.